आजा।
So, good morning all my friends. So today we are going to solve a question number 24, which is based on application of derivatives. Now we will solve the given question. In the question, it is given that show that the right circular cone of least curved surface area and given volume has an altitude equal to two times the radius of the base. So first, in the question it is given that we have a right circular cone and the curved surface area of that cone is least, it is the minimum. And the second part of the question contains that it has an altitude equal to the root 2 times the radius of the base. So first we will find out the CSA of cone. First let me draw the picture diagram of cone. This is the height of the cone and this is the slant height. This height is known as slant height and this is the radius of the cone. So first we will write these all things. So R is the radius and H is the height and L is the slant height of the cone. So first we will write the formula of volume of the cone. Anybody can answer? Volume of cone. Yeah, right. Volume of cone is equal to 1 by 3 pi r square h. Now, suppose volume of cone we are representing as V. Then it is V is equal to 1 by 3 pi r square h. Now, we will bring all the constant terms at one side. Then it will be 3 will come here. It is in denominator and division. So when it will come here, it will get multiplied with V. So it will become 3V. And pi will come here, it will be 3V by pi is equal to r square h. Now we have to assume that this 3V by pi is a constant and that constant is equal that constant is k. So because if we will consider k, then our further calculation will be easier. Write it, assume k is a constant and k is equal to 3V by pi. So in place of 3V by pi, can we write k?
Yes.
Yeah, then we will write it. It will be k is equal to r square h. Now we will bring this radius in the denominator of this k. It will be k r square is equal to h. Now some of you may have doubt that why we are finding the value of h, because in the further calculation we need the value of h to find out the slant height of that cone. So because of that reason we are finding out the value for h. Now this value we need, so I am writing it side square. Now, in the question it is given that circular cone of least curved surface area. Means first we will find out the CSA of cone and then we have to prove that it is a minimum. Then we write formula of curved surface area of cone. Anybody? CSA of cone? Pi r. Yeah. So CSA of cone is pi r L. Now, suppose we will represent CSA of cone as S. We write S pi r. Now, L is what? Slant height. There is a formula for slant height, that is L is equal to under root h square plus r square. So, in place of L, we will substitute this. Previously, we have found the value of h and that is k by r square. So, in place of h, we will substitute k by r square. Then it will be in place of h, we are substituting k by r square from here. And it is h square, then it will be k by r square whole square. Now it will be pi r under root k square by r to the power of 4 plus r square. Now just further calculation, simplification. Now r4, we will take this as we will do LCM of this. It will be r4 k square plus r to the power of 6 according to law of exponents. Here r4 is at denominator and here r square it is there. So we know in LCM we will do multiplication r square into r to the power of 4. So its power will get added. It will be r to the power of 6. Now further calculation. Now here we have to cancel this root, under root. So we will do squaring on both sides. After squaring on both sides, it will be s square is equal to its square, it will be pi square into r square, and under root will get cancelled, so it will be k square plus r to the power of 6 by r4 in the bracket. Now as we can see this r square and it is r to the power of 4, so we can cancel this. It will get cancelled, it will be r square, and then pi square we have multiplied with 1 by r square. It will be pi square by r square, and it will be as it is a square plus r to the power of 6. S square is equal to. Now just we will open the bracket, then it will be s square is equal to pi square into k square by r square plus pi square into r to the power of 6 by r square. So here also we can cancel, then we will cancel it. After cancelling, it will be r to the power of 4. Now we have found the CSA of the cone, and it is the question they are telling that we have to show that this CSA of cone, it is a minimum. So for that we will consider this term as a function f of x. We will consider this as pi square a square, and it is in the denominator. If we take it as in numerator, its power will be in negative form, minus 2. It will be as it is. Now some of you will have doubt why we have taken this in numerator. So because we have to differentiate it. So if we take this up, r to the power minus 2, our differentiation will be easier. So because of that reason we are taking this in numerator. Now we have to differentiate it. Differentiate with respect to r. So for differentiation we will do d by dx of this whole term, y square a square r to the power minus 2 plus pi square r to the power of 4. Now as we know that pi square and k square, these both terms are constant, it will come out. It will be pi square into k square d by dx of r to the power minus 2 plus, here also pi square is a constant, it will also come out. It will be pi square d by dx of r to the power 4.
That will be d by dr.
Yeah, sorry. It will be d by dr. We are differentiating with respect to r. Then differentiation of r to the power minus 2. What it will be?
Minus 2 r to the power minus 3.
Yeah, it will be minus 2 r to the power of minus 3 plus. Here, what will be the differentiation of r to the power
cube?
Yeah, pi square 4r cube. Now we will multiply. So f of x is equal to, we will multiply this term and we will multiply this term also. It will be minus 2 pi square a square r to the power of minus 3 plus, and now we will multiply this. It will be 4 pi square r to the power 3. Now this is the differentiation. Now we have to equate this with 0. So we will equate it. Now what is the differentiation? 2 pi square a square r to the power minus 2 plus 4 pi square r to the power 3 is equal to 0. Now we will take this term here. 4 pi square r cube is equal to 2 pi square k square. It is r to the power of minus 3. If we take this in the denominator, it will be r to the power of 3. So we will take this here. Now we can cancel this. And 1 2 pi square r cube, it is in denominator. Now it will come here. It will be r cube into r cube is equal to k square. Now, as we know law of exponents, so according to that we will add the powers. It will be r to the power of 6 is equal to k square. Now, we will double differentiate this. Double differentiation of x, it will be d by dr of minus 2 pi square k square r to the power of minus 3 plus 4 pi square r to the power of 3. Now we will differentiate this. So first constant, all constants will come out 2 pi square. Now differentiation of r to the power of minus 3 with respect to r plus 4 pi is a constant, it will come out. Now differentiation of r to the power of 3 with respect to dr. Now we will differentiate it. So first constant as it is, what is the differentiation of r to the power of minus 3?
Minus 3 r to the power of minus 4.
Yeah. So we'll write it minus 2 pi square k square. Differentiation of this, it is minus 3 r to the power of minus 4 plus constant as it is. Now differentiation of r cube, what it is?
3r square.
Yeah. It will be 3r square. Now we will multiply this. It will be plus 6. Minus 2 into minus 3. It will be 6. Pi square k square r to the power of minus 4 plus, we will multiply here also, it will be 12 pi square into r square. This is the double differentiation. Now it is r to the power of minus 4. Then we will take this in denominator, it will be r to the power of 4 plus 12 pi square r square. Now, what do you think? It will be greater than 0 or less than 0? This term, it will be greater than 0 or less than 0?
It will be greater than 0.
It will be greater than 0. Therefore, f of add k square is equal to r to the power of 6. F of x is a minimum. This only we have to show in the first part of the question, that the right circular cone has least log surface area, and it is, we have shown that it is a minimum function. Now the second part of the question is that altitude is equal to 2 times the radius of the base. So altitude, it is nothing but height. First we know that h is equal to k by r square. Now k by r square, h is equal to k by r square. Now we know the value of k square, that is r to the power of 6. Then we will substitute.
Go.
Now we will square this term. Square on both sides. you may ask why we are squaring here. Because we have the value of a square, and that is 2 into r to the power of 6. So we will square it. So we will square it. It will be a square by r to the power of 4. Now we have the value of k square, that is 2 r to the power of 6 by, it will be r to the power of 4. Here are 4 and here are 6. We can cancel it. It will be x square is equal to 2 r to the power of 2r square. It will be it is x square. If then x is equal to under root of 2r square. So we have h is equal to r square. For this, root will be cancelled. So it will be root 2 into r. This only we have to show that the altitude of that cone is equal to root 2 times the radius of the base, and we have shown. So thank you.